Okay, so hi everybody. Once more, I got a notice that everything should be ready now. So recording should be ready, and so just my colleague left, but he will present right after me. So I will start. So welcome again. Thank you very much for your attendance. It's from my perspective, it looks quite a lot. This is not gonna be like a funny live stream on Twitch or something like that, or some funny live stream on YouTube. It's gonna be a little bit more serious about the topic is cybersecurity, and then we will follow with the AI and machine learning and this kind of stuff, which is basically quite popular and common discussion these days. So hope you're gonna enjoy it. My name is Andrej Jeleník, as it is on the slide. I'm a Cisco solution architect. They change these name of the roles quite often. So we used to call ourselves like systems engineers. So you might be more familiar with those. But still, we are working with technologies. We are doing technical stuff. Me and my colleague Peter Morvay, who will present right after me. And we do a little bit of business as well, but we are not taking care much about prices, about these things. We are consulting with our customers, the architecture, design, and helping to solve their, not problems, but challenges. So this is our goal. This is our mission, let's say. So me myself, I'm focusing on cybersecurity for quite a long time. It's gonna be maybe 15 years already when I started to play with the first firewalls, and so I'm working with Cisco for 10 years. And all the time I'm spending to learn more about cybersecurity. It's so a huge topic that it never ends, that's for sure. And I think the most important thing is that it will never end because the cybersecurity, there are guys who are a little bit like a step ahead. And we are trying to chase them, and vice versa, right? Like the hackers and the criminals who are trying to do bad things, earn some money, or just damage some, let's say, brand or whatever. There are many reasons. There are, of course, also reasons like much higher multinational, where governments using cybersecurity for good and bad things. Okay, let's go to the concrete and specific things. I have 7 topics for you today. The first one, well, if you don't mind, I will go to this side because I have my laptop here, so I don't need to watch behind me. The first thing I would like to start with is the threat intelligence. I think it's the most important thing when you think about cybersecurity solution, because every cybersecurity solution is focused on something, on end user, on some perimeter, or some another communication vector. But threat intelligence is something which is common for every cybersecurity solution. We will talk about it a little bit more. In second topic, I have for you the overview, which are observed and emerging threats this year. So, you're going to be informed what's the potential threat out there in the cyberspace. Then I'll show you the architecture, how it can look like, or what all solutions and products, let's say, let's call it products, but I like the naming solutions. It is composed with. So you will get an overview of this architecture. Then I'd like to spend some time, not much, because these topics like zero trust architecture or secure access service edge or XDR, extended detection and response, those are quite huge topics. But I have a particular reason why I chose them. They are most popular at the moment. Most our customers are talking about them, want them. Some of them already are working with these solutions, with these architectures. I think, from my perspective, it's not future. It's here. It's here. It's now, but it's still kind of new. Let's say, at least like SASE or XDR. At the end of my blog, I'll talk a little bit about machine learning and AI, artificial intelligence. Mostly, I'd like to show you some examples how we use AI in cybersecurity these days, what we have available, or what we wanna, or where we wanna get in a near future. I don't want to talk about science fiction. I'd like to show you what we have at the moment. I'm from Cisco. I will mostly use Cisco slides, but you can think about it in general. Like these products are available from the other vendors as well. Some of them are very similar. Some of them are maybe a little bit better. Some of them are maybe a little bit worse. I don't want to talk about these differences or talk that we are better than the competition. Maybe it's going to be better to focus on the practical side, let's say. Okay, let's start. What is threat intelligence? Is here at least one person who doesn't have any idea when he's listening this wording like the threat intelligence? Raise your hands. Just don't be worried. I'm not gonna give you an exam and give a grade. It's just for you to know. All right, don't worry. Threat intelligence is basically the knowledge the products can work with. Let's imagine there are many new threats which are out there on the internet, and they are chasing for the victim. I don't know, ransomware, and so on. And the solution, who is, let's say, inline, and it's inspecting the traffic, the communication inline, have to have a knowledge about these kind of things might exist, right? So threat intelligence is the knowledge which is very specific, which is very unique, let's say, which each vendor on the market, as Cisco is, and the competitors, usually have their own threat intelligence. There are also alliances who can share this threat intelligence, and that can bring those solutions like more effective and stronger, let's say. Cisco is kind of unique with these because, as you might know, we have quite a huge the backlog with the customers all around the world. So many customers are using our switches, routers, firewalls, and let's say communication devices like the Cisco collaboration and stuff. That's why we have a really huge amount of data we can work with, we can analyze, and we can do the big data analysis upon it. So that's the reason why this threat intelligence, which has the group who is making it and working with it, called Talos. It's kind of unique, and a lot of competitors would like to have the same, or would like to have at least a bit of it. So, long story short, threat intelligence is the most important thing to do cybersecurity effectively and do it the proper way, right? So if you have a firewall who is able to inspect the communication but doesn't have a knowledge about potential threats, you will not catch anything, and you will not protect the users, the data, the network, because you don't know that might exist. If you have the threat intelligence, a good one, you can do it effectively and properly. Cisco Talos, which was mentioned there, which is like group inside the corporation, inside the Cisco organization, is working, as I said, with a big amount of data. Just for you to imagine how it might look, it's about 550 billion security events every day. So it's really huge. It's probably not imaginable, but yeah, it's really huge. Like 9 million emails blocked every hour. So you will see later one of the cybersecurity products from the cybersecurity portfolio of Cisco are also email gateways. They are very popular also here in Czech Republic. Almost entire public sector is using them, but also many small, let's say small, big, and also like a very large companies are using them as well. They are very popular for quite a long time. They have a long history. So these things, like 2,000 new samples every minute, it's a huge. You might think, what kind of data are these? If it's like, if it's just a log, if it's raw information, or so. Yeah, definitely, it's a good question. They have to be anonymous. Everything is not connected to concrete or to the specific company, person, and so. We are doing the analyses which are made upon it are all anonymous and not touching or connected to any of the customers. So that's why it can work like this. So you now know what is the threat intelligence. You now know it's a huge amount of data behind that. So a lot of analytics. And what are the observations? There are every year this group, Talos, is making a report. Usually it's in the beginning of the next year. So I have now data in my presentation from the first and second quarter. And for the third and fourth quarter, it's going to be available in January or February. It's a published, it's published for everyone. So it's not something you have to pay for. You can go to talos.com or Cisco Talos. You can Google it easily, and you can read through the report. It's really informative and interesting, I would say. Also for the people who are not spending hours a day with the cybersecurity or are just curious how it looks in the cyberspace these days. Most targeted industry for the past year is healthcare. You might heard from the news or from television, from the other sources of the news, that this is really true. I would say it's sad, because healthcare is something which should be not touched by these things, right? It's something which should be supported, not, let's say, degraded. But yeah, it's there. Of course, huge impact on the cyberspace and on events which are common for the cybersecurity. For the cybersecurity analysts, are also events which are happening in the world these days. So wars, conflicts, and these sad things. So this is also rising, let's say, the danger, not only for the companies and the huge organizations, but only to individuals. You might be aware of, or you might have somewhere around you who was a victim of, let's say, social engineering stuff, like someone is trying to get money from you, but you don't know about. Like, I don't know, you are selling on Vinted, or you are get in touch into communication from other services like that, and those people are trying to convince you that you have to use the separate way of a payment, not the one which is integrated in the application. That's how it usually starts. I know many people around me living here in Czech Republic, in Prague, who actually got stolen like thousands of crowns, or let's say hundreds of thousands of crowns this way. Why so? Why those people are doing this? One of the ways, or actually one of the information I got from the police when I was cooperating on this kind of the crime was that there are organized groups who are through these ways trying to support the war, one side or the opposite side. So this is the one thing. The other thing is these threats are in the cyberspace, let's say, quite common. Not that kind of amount, but they are quite common, so they are persist. And these are the reasons. If you have any questions, if you are interested about something specific, just raise the hands or yell on me. I'm completely okay with that. So we can do the discussion. I will be happy to do so. That is basically the first threat, which is there with the banknote, the blue one, data theft, extortion. They usually use like valid accounts for that. So these criminals are not necessarily need to steal your credentials to get into, let's say, internet banking or using your credit card. You will give it to them. They will convince you by the social engineering to give it to give it to them, and you will do so because you are trust them, and you are completely convinced that I need this sweater or something, and I need to buy it for 200 crowns because it's the best price ever, and they will convince you. They will send you, let's say, a parking web portal, which is not the proper one. Let's say it's not how I say, yeah, it's not genuine, and it looks like, but it's just looking like that, and you put your credentials into it, and some keylogger on the other side of the side of the criminal is basically reading what you are putting into those columns, and they are doing the authentication on the proper portal of the bank. And basically, you don't know, you think you do it, but they do it on the background, and they are also making the payments, the transactions and stuff. You still think you are doing it at that correct moment, but no, somebody else is doing that on the background. You will get a notification that this transaction needs the authentication. You will accept, let's say, and they are basically there. They will send the payment you are expecting, but at the end, right after that, they will basically clear your entire account, like a bank account, right? That happened, for example, to my neighbor who was just about to buy a sweater, as I was mentioned before, and they basically on that account they left just 2,000 crowns. Like it was kind of polite, let's say. Yeah. The other topic which is very common, and it is basically targeting similar goal. It's getting into accounts like on a social on the social media like a Facebook, like a Gmail and these kind of personal accounts. Most of the people are still not using multi-factor authentication. What about you? All of you are using multi-factor authentication? Okay. I'm pretty sure that you are aware of the complexity of getting into your account if you are using a multi-factor authentication, and also if you are not using it. Of course, the complexity of your passport might be high, might be difficult, but there are still a lot of methods and techniques how somebody can break it. But if you have the multi-factor authentication, another factor, which might be the face recognition, which might be your print screen, fingerprint, or these kind of things, which comes to using your phone or using your tablets and stuff which is personal to you. This complexity to get an access to your personal accounts, it's much more difficult. And basically, if it's not somebody who is sitting next to you and might have an access to your mobile phone or these kind of personal devices, it's impossible. It's mostly like impossible. So multi-factor authentication is available there for all the social media accounts and these services. Google, Facebook, and the others like Twitter or X, is how it calls these days. Everybody's offering this, mostly using one centralized application which calls Authenticator, if I'm not mistaken. So definitely do it, because this is really like a really weak point. How the criminals, hackers, can get access to personal accounts using. We have just one screen again. Are you okay with this? Can we work like this, or should I call support? Good. So let's continue. Yeah, that's quite common. Yeah, there is a lot of emails and let's say messages which are trying to drive you away and hook you on something which might be interesting for you. Like as you said, if there is a message, you having delivery guy waiting for another fee, really small one, like 20 crowns or something, and you are curious what the kind of package is going to be. I'm not expecting any, but if there is something interesting, I'm going to be happy. So, yeah, you do it. But there are also like phone calls, which are targeting more on, let's say, old people. I know a few who was dealing with this. They are trying to convince them that somebody's already hacked their account, let's say, and they have to go to the bank, get all the money from the account, and put it on another one. And they do it like so precisely, and it's so like a trustworthy that the old people are really going to bank, and they are putting this in the Bitcoin ATMs. And it happened here in Prague, not like 1 or 3 or 4 times. There are tens of examples that all people are doing this. That you might notice, for example, in Pankrácz Arcady or some other these ATMs for Bitcoins. So the police officers are going around and stopping by for quite often than before, because when some old people started using them, it's weird. Yeah. It's a little bit weird, and it's suspicious. So they are trying to help them. There was also a case. The one old gentleman was doing this by the ATM, and the police officer came and told him, "No, this is a scam. It's not real. Somebody is trying to get money from you." And he was like, okay. he jumped to the tram and went to another ATM and put the old money there. So yeah, this is happening as well. There is a prediction what comes next. Of course, there's going to be more ransomware threats. Ransomware, you might be aware of, it's let's say, it's a software, very like simply saying, it's a software, unwanted, definitely, which you might download from some attachment, from some website and stuff, and he's autonomously building the application on the background of your operational system, and trying to encrypt your hard drive. And when it happened, it will give you a message that you have to pay for the key to get back to your data. So this is ransomware. There are a couple of examples there which are active at the moment, and you might catch them. But there are going to be new, definitely, because these kind of threats are quite good money-earning stuff for the criminals. Of course, there are going to be always DDoS. You might know what is DDoS attack, where somebody is trying to, let's say, degrade network services or some other services of a web portal, eShop, or stuff, so they can buy it on the internet, and somebody will work for them to create multiple connections to some destination, and like overwhelmed the service this way. Phishing and service tools, phishing and a scam, that's what we were talking about. Those are those messages who are trying to hook you on something interesting and get the access to your bank account and stuff. And definitely, yeah, pure extortion. Yeah, I was talking about this. Let's jump into security reference architecture. I will put it all on. It might look a little bit complex, and it is, but I don't want to spend like a lot of time here. I just would like to show you the most important, let's say, vectors, which are or from which are the cybersecurity made of. When we are talking or we are thinking about cybersecurity architecture, we have definitely a couple of segments on mind. The first segment is a user and device security. So user is going to be always the weakest part of the cybersecurity. User is the one who will communicate with somebody else who might be criminal. User is the one who is who is clicking like crazy on the links, and he or she is not controlling them if they are proper or not. User is one who is bringing to cybersecurity analysts and cybersecurity engineers the nightmare into their lives. So we used to say in cybersecurity, there is not patch for stupid, and it's quite clear, right? So if someone is not aware, so there is threat, and it's not danger only for them, but for society, for the company, and for more people around. They will act like crazy. So the user and device security. So there are solutions who are focusing or which are focusing on the access to the network, to access to applications, to services. On those particular users, we are working with the identity. You might know, or you might see before that companies are using identity stores, identity managements, and these kind of solutions to have a database of users to be able to do a proper authentication and authorization to the services and to resources in their companies. So these all are, let's say, in this block. users are these days pretty much, let's say, I would say they are still happy if they have a choice to work not only from the office. They would like to work from the cafeterias. They like to work from home. So us as cybersecurity, let's say, admins, engineers, architects, we have to think to bring them the same level of security in every case, in any of these cases. So if they are working from home, they can use VPN. You might know VPN, right? So it's a private encrypted connection, which is basically terminated directly into the company, and the bridge into it's completely encrypted, so nobody can read or watch what the communication is. So this is the one thing. Of course, there are other options how we can do it by the agents, which might be running on those computers, on those cell phones, on those like smart devices. We can achieve this. We can achieve the same level of security for everyone working from everywhere. Then another segment, which is the biggest one, is of course the network. The network, like the company network, which might be segregated into various segments, like a data center, like the access. The access is also might be segmented into other smaller segments, like the access for IT guys, the access for the administrators, the access for accountants, the access for whatever role you might have on mind. So it's good to be segmented on these parts. The other thing which comes when you think about the network security, it's connecting like multiple networks by the locations, let's say, like in the different geolocations. This connection we used to call like a wide area network. You might know this abbreviation. There is also another like perspective you need to think about. You need to protect also this connection between multiple locations. You might use this opportunity to tune up this connection for quality of services, for monitoring, for gathering the data, which might be useful for analytics, for tuning up those services more. That's a thing we call SD-WAN. Like a software-defined WAN. I will talk about it in a minute. Of course, there are those disciplines, architectures, designs, which I'm going to talk about on the next slides. How many minutes I have? Like 7 minutes? Oh my God. Okay, I'll skip this for now. There are more segments, right? Important is to realize there are also applications. We have to secure those applications as well. We have to secure the access to the applications. So not legitimate access, it's not provided, and stuff like that. It's quite complicated stuff. Or when you think about it as a concept, as an architecture, there are many elements into it. As you can see on the above, like which is covering everything there, it's a threat intelligence, which I was starting with today. Okay, just 2 sentences here. What are users expecting from the network? So users are expecting that the network is going to work, right? That the wireless or the wire network access is going to work, and they don't care what kind of protection they get. They want to be protected. They just don't want to be limited, and they want to get access easily. They want to use services and use resources to do their jobs. Of course, on the other side, there are admins, and those admins are also their wishes. And most likely their wishes are, you saw the slide before. there were like 15, 20 products on it. So you can imagine if you are alone in some company and the company can cover and every vector, every single vector and every single vector which might be like potential threat going through it, they need all of these. But the admin might get crazy, right, with those many products to taking care of. So basically, the admins are wishing to have a centralized console where they basically can monitor all of these solutions and be aware when something is happening. To have alerts which are like a real time and even better if those solutions can do something like autonomously, so they can automate. They can automate the processes which are common, which are like repeating and stuff. So automation and centralized, let's say, the dashboard, which might work for them centrally for all those solutions. So these are wishes of the admins. Of course, there are other things which need to be like considered when they are thinking about the security. Zero trust. You will hear about it if you did not till now. You will definitely heard about zero trust in the future. It's basically the idea trust no one. So you should be as the admin, as the security guy, aware of everyone and everything which you have in your network. It's quite clear, right? It's quite reasonable. If you don't know about something in your network, you can't protect it. You can't protect against it. So you need to know. But it's not essential to have that kind of visibility. Zero trust principles are talking about these enforced last privilege access to everyone. That means if I'm an IT guy who is working on, let's say, building the software, I should have access to resources which I need to have for doing my job. But all the other resources which might be focusing on finance, on the purchasing, on, let's say, other kind of applications, I should not have access to it because it's not my responsibility, it's not my job. So this is quite easy saying how this concept, how these zero trust principles are working. Again, there are a couple of products which are behind this. There are products which are working with the identity, so something like a radio server, identity services engine. It might be something which is able to do a posture. It's a thing. It's a feature which might be there for monitoring and controlling the health of the device, which is in the use of the person, of a user who is connecting to the network. If the computer, for example, which he or she is using, it's up to date with a service pack of operational system, if it has antivirus installed on, if it's, I don't know, if it's decrypting the hard drive to have this, and so. It has other specific requirements for segmentation. So as I was talking previously, the network needs to be segmented. So for example, IoT devices are on the different segment of the network as the users who are, for example, working with the sales applications and stuff. And IT guys, for example, might be on the different segment because they are accessing the specific, let's say, services and need a specific type of communication within a network. So the segmentation as well. Continuously verified trust means I can get the access to user who is connecting to the network because I see in my identity management database, I see him, see her, but he might changing the location during the day. He might be connected to the network from here, later on from the other part of the building and stuff. And these might be opportunities for me to re-authenticate. The other thing, there might be on mind the idea I was talking like 5 minutes ago. Users are expecting the services and connectivity is going to be there. It's going to be simple to use, and it's going to be working all the time. So the zero trust architecture is thinking about it as well. Respond to change in trust. So this is the thing. The conditions might change, and I need to be aware of it. Secure access service edge architecture is something some other perspective. This is bringing us back to the idea that people want to work from everywhere. They don't want to be limited by coming to the office at 9 a.m. and leaving at 5 p.m. They would like to be flexible. They would like to have flexibility, and they would like to have same level of security from everywhere they might be working. So secure access service edge, it's for example the solution who can achieve this goal. The principle is very easy. Let's imagine the user like a roaming user, somebody working from the office, somebody's working from the branch, are going through the same service provider, which is the secure access service edge, located in a cloud, so basically in the internet. You can imagine it as you are sending hands over. What happened?
Maybe now it's time to go.
Okay. We're back. Okay, it looks that the right side is gonna get rest, and we're gonna use the left side for a couple of more minutes. The idea is simple. You will forward the traffic through the same point, and that point will inspect the communication and give you the services and features you need. Those services and features you need might be like a cloud firewall, which is inspecting protocols and ports. It might be like a next generation firewalls, which is inspecting signatures from the threat intelligence, the knowledge base, and searching for known threat. It might be integrated zero trust. There might be integrated like a remote browser isolation, but even more like we are thinking about inspecting and controlling the web traffic as it is. So we might have policies set up for categories of the websites. So if we're gonna raise the productivity of the people, we might select some categories which will not be accessible over some time. And so you can imagine this way. It's really a huge topic, and I think the only idea I would like to have, you can take with you when we finish today, is that this kind of solution exists. So if somebody say, we cannot let you work from home because it's not safe, just give them my name and I will explain them. It's possible and it's very easy. And many companies and organizations are looking for it at this moment, at the moment, because after the crisis we had a few years ago with the COVID and these things, these sad things, the conditions changed, and if somebody say, like a new trend is coming back to office, it's just basically up to you, only up to you. Nobody will drive that trend without you. So yeah, we can achieve the same level of security for everybody who want to work. XDR is a console which might get the administrator the centralized view through entire product portfolio of cybersecurity, which might be there. All those products I will show you on a white slide, the complex one, might be integrated through API or through integration platforms into these dashboard, into these console. it can bring the administrator, security operation teams, and analysts a lot of advantages and make their work much more efficient. Why? Because if you integrate these products together and see the context of each product in a same dashboard, in the centralized dashboard, you might see the connections there. So if, for example, endpoint security agent realize there is a threat, there is a virus, there is a ransomware on that endpoint, you can react on that quite fast and, for example, isolate through another product that endpoint from the network, that the threat is not spread to the other computers autonomously, right? So these kind of things might be available for the administrators there when they have a broad view through those products in one place. Of course, investigation, auditing, and stuff, it might be much more easier and much more effective. So this is the thing. One important thing, this is not only for Cisco cybersecurity portfolio, it's open. So it's interesting even if the companies go in multi-vendor solution, not only single vendor solution. Okay, and the last thing, I will not spend the time with these. This is like an example how it might look when you go to specific incident and you see through like the more solutions. As I'm running on time, I will just skip this. You will have a chance to go through those slides by yourself later. I'm going to share it. And definitely, if you have any questions, and I hope you all have some, you can contact me through your lecture. I will be happy to help you. Okay, I think this might be interesting topic for you. Artificial intelligence and machine learning. My colleague Peter will continue on that. I'd like to focus in the last 2-3 minutes how AI and machine learning is applicable in things like cybersecurity solutions. And as it is there for quite a while, it's not new. When it comes to this wording, you might hear related to artificial intelligence also like machine learning, artificial neural network, or deep learning. I'll focus myself on those first two. My colleague will go a little bit deeper if you like. But let's see, machine learning. Have you heard about the machine learning before? Anybody of you? Cool. Machine learning is something which is here for quite a long time. For example, in computer networks or in cybersecurity, we use machine learning for years. If I have a solution which I'm expecting is going to give me some alerts on using a network, I need to know some baseline of a usage, right? And this is, for example, a very simple example of machine learning. So my solution with monitoring the network might learn how the network is in use every day and can create some baseline. If something exceeded the baseline, I will get an alert and I can do some action, what is necessary. This might be a little bit more complex with the cybersecurity and hunting the threats, let's say. But it's there. It's a little bit more complex, but it's working on the same principles. So I can monitor, let's say, internet. I say it so generally, but yeah, we are doing this. We are monitoring segments of the internet. It's basically like using a Hubble telescope and watching one like a small dot on the space. It might look like that, but of course now we have a really huge performance of computers, so we can do it effectively. And if we are doing it systematically, it might work and it might be informative. It might be good for our, let's say, building threat intelligence. So machine learning is there. We can get some baseline from using of services using applications and stuff. If that baseline is exceeded, something's changed, I can be informed about it. So how machine learning helps the security in specific cases? Find threats on network. This is what I said. Network is behaving on some baseline level. Something is different. It might basically alert the administrators, so should focus on something. If we have a central console, as I was showing before, the XDR, these might have in a real time, at a specific moment, already a few connections to the other events which might be happening in the network, and the threat intelligence is able to tell me, yeah, this threat goes like that, and this is the step-by-step, let's say, manual, what you as an administrator supposed to do, and how to protect and remediate the network. Keep people safe when browsing, provide endpoint malware protection, protect data in the cloud, stealing data, for example, also, like the monitoring system, the solution, is learning the behavior of the users. These users are usually sending and receiving this kind of amount, which might have some specific number of a range. If that changed, it might be the indicator that someone is, for example, stealing data or sending data somewhere from the network. So machine learning is interesting, and we're using it. Machine learning might be also this kind of cascade of specialized layers of the machine learning, like algorithms are used in some layers. The cognitive intelligence we use when we like to predict if there is some threat in the encrypted traffic. You might be aware of that most, as 80% of the traffic today is encrypted. That means nobody see into it. But we have a methods, we have a machine learning, which can quite specifically say, in this encrypted traffic, there is a threat. There is, for example, DDoS attack included. There is ransomware, which is sending from some destination to, from some source to the destination and stuff. And we do it by this cascade, using these cascade algorithms, which are built on the statistical methods, mathematical methods, and doing a lot of calculations and mining using neural networks to get to the result. And the result might be name the threat and give the guidance how to get rid of it, how to remediate. The last slide I have, is the example how we use AI these days. I didn't mention in the first slide, the machine learning is something which is analyzing the data and trying to get from package of data, from many data, some result, which is Peter will specify it a little bit better than me. I think in one side there is a huge amount of data. On the other side there is a result, and the learning in between is able to teach the system if something is what I'm expecting. Like there is a very nice example of a muffin and how it calls the dog? And Chihuahua, how the computer can learn if it's muffin or Chihuahua by the machine learning. AI, on the other side, it's an interface, let's say, who is expecting to behave as a human. So it's like interface for the machine learning, very simply saying. We use AI these days in our firewalls. So you as an administrator don't need to browse entire dashboard and look by yourself for how it's if some policy is applied, or if you need some more policies to get some protection. but you can just ask AI, and you can simply ask AI, do I have a rule for this or that? And the AI will just read your policy table, let's say, and will give you back the answer. Yes, you have this, but you don't have this one, and it's important. It might be there as well. Should I do it for you? And you just say yes, and the policy is right there. So this is the way how we will very probably use the AI in the future. Of course, when it comes to AI, there is a lot of discussions about privacy, confidentiality, and stuff. So this is proprietary version of the AI. It's not using OpenAI or the others, right? So this is the thing. Okay, thank you very much for listening. I hope it wasn't that much mess. I hope that you got some information which might be usable for you. Or I will give a word to my colleague. I'll be here, and also after the lesson, we are going to be here for you. So if you have some questions, something on your mind, just tell us. No, ale nemáš ho tam.
A? Good. Wow. Zkuste prosím zapnout ten druhý. Já si myslím, že se vypne totiž to. Hello, so I hope you are not sleeping yet. You are also not going to sleep after my presentation. My name is Morvay. I am systems architect. I'm getting used to of the term. Thanks. And I work also at Cisco with Andrej. So everything what he said about our work is there. And I will talk about AI in networking. So AI. We all keep hearing about it, and it's here, it's sexy, it works, it saves some time. I'm sure that many of you have used it. Many of you have used it even though that you do not know about it. And I have some slides like this one. 76% of organizations are going to prioritize about AI. Basically now, when there is some CEO and he's talking about the strategy and he does not mention AI, a lot of people understand that, oh, maybe that company does not have so bright future. Maybe, maybe not. There were already few hypes around AI, and I was just discussing today with the colleagues, and they told me that they are enthusiastic, but they don't think that this is going to solve everything. We are still going to have some work. We are still going to be relevant. So, for example, first this hype that they mentioned is if you have ever sent a postcard and you wrote the zip code. Imagine how many postcards still even nowadays is sent, and just imagine that there would be a person looking and checking these zip codes and just sorting everything out. So this was done already in 1960 by some neural machines, the neural networks machines. So really imagine how long time it is. It was quite simple. In some countries they had it a little bit easier, that you had lines, how you selected the number, but it was there. So again, AI, and let's see where it brings us. I will talk a little bit about the overview. This is not a data scientist presentation. Maybe you know about many of these terms. If you want, just add a little bit more. And then we will focus on some examples and some trends that we are seeing, and also where is Cisco relevant in this space. So, humans. We as humans, we are learning from experience. Either our own experience, what we see, what we try, or we learn from the books, from some trainings, from courses like this one. Basically what we see. Then in the middle there are computers. Simple programs. We just write a code, we put their instructions, and we usually exactly know how it will work if there is no error. And how about the AI and machine learning? These are algorithms which are consuming, analyzing a huge amount of data and trying to find some answers, some patterns, something what they can harvest out of this data. And very often, the quality of outputs is dependent on either amount of data that you have and also about the processing power that you have, how many iterations of the learning your algorithm can go through. And you have seen this slide, very similar already. So what is AI, artificial intelligence? Basically, this is anything what is mimicking a human interaction. So it does not have to be the ChatGPT or something what writes the essay for you or create a slide like this one. It can be anything, any algorithm, any bot, even in some chat application that replies and try to look like a human is also considered like AI. So it's really, really wide. Have you heard about the Turing test? So it is a test, and now I don't remember the year when it was broken or passed. Basically, there was a goal that some algorithm will cheat a person that it is a real person. So there were one person and one algorithm, and the person who was the judge was supposed to be not able to say this is a person and this is an algorithm. So we are already in the stage when in many cases you cannot from a standard communication see if there is a human or some machine or some algorithm. Machine learning, processing of data, neural networks. This is an algorithm which is trying to behave as our brains, as the synapses, as our brain is working. I will discuss a little bit more. And deep learning is part of the data science, where from the data, using these ways to find some solutions and some answers in the data, even though that we do not say that this is what you should be able to distinguish. With the deep learning, the algorithm itself can find a solution. The example here is, maybe you heard that, I think it is already like 5 years, Google, they were teaching some algorithm on the YouTube videos. And it came and said, and they're able to distinguish that this is a cat. And okay, I can distinguish this is dog, this is a cat. But the interesting part on this is that they didn't say that look for an animal, look for some mammal. They just said find a pattern. And it was able to say this is something, and from the comments or from the names of the videos, I'm able to find out that this is a cat. So it was like new milestone that the algorithm was doing by itself, using the deep learning. And here is the famous muffin and chihuahua challenge. Imagine that you want to process some pictures. And in this case, it is to distinguish whether on the picture there is a dog or there is a cake. And sometimes it's really easy, sometimes it's slightly harder. And let's use machine learning for this. And very, very briefly how this works. So we have a test model. This is a library, very often in Python, that have some purpose, and we just use it. You are just using this library, you import it, and just briefly specify what you want it to do. Usually it is for some specific purpose. I will show you some example. Then you have your training data. Again, remember, sometimes you do not have enough training data. it might be an issue. Maybe in this case, you can search the internet and grab everything, but if you want to process some specific case, some specific logs, or to have something that is not freely available on the internet, or there is not enough data, this can be also an issue. So you take these two, and you start your training process. So first you collect these, you clean the data. This is part of the data scientist mystery. Imagine that if you are training your data on inputs which are initially very strange, that you will be getting strange results. So at least initially, you really want to have your data very clear, so the results from the first iterations are also easy to process, easy to guess, and then you can add up slightly harder to guess inputs. And then you correlate and train, and then you have your result, and you go again and again and again. This is called the training phase, and out of these you create already taught neural network or taught algorithm, and then you have your model, and you are using it in your app. You have your real new data, and you find out if it's Muffin or if it's Chihuahua. And here, the training process is really computational hard. So usually you need nowadays big GPUs and a lot of money for the power. Not only buying the machines, but also to have the power. Yes, this is a really good example, and Yes, let me go to the next slide, and I will mention this one. It's a really good example. Okay, so there is the training phase, supercomputers, and then there is called phase interference. When you have already your model, and you can have this one even on your phones or on your personal computers. So depends on how big is the model. You can even have it inside your app. So the neural networks and deep learning. Here it works so that you have some picture, and from this picture you take every single pixel, and that's your input. Then on the other side you have some outputs which can either be yes or no, dog, or it can be a ladder, and then you are processing the data, and then the neural networks, they work that these in the middle, those are indexes. So there are some numbers which are processed, and if they are and then they have some output which is, and then which of those has the highest value, then that one is selected. So, and imagine that the first run is that you just take the initial pixels, you have some random numbers here, and then you get the result. And if it's successful, if the result is correct, then you set to zeros the other outputs and try to repopulate this backwards and adjust the indexes. And it works again and again with different pictures. And what you mentioned, when I was learning this, I saw some really good video, and they were presenting this on the captcha, but of the numbers. And it was very interesting that they tried to find some pattern. Like when we have the number, there is on some specific pixels, they are on. And based on that, they were selecting how many middle layers there were supposed to be. That was a real science. But here with the neural network, you can imagine that basically you have some inputs, you have your result, and then indexes in the middle, and you are trying to have the model as precise as possible. And in many cases, we do not even know how it really works. There are just some numbers. They are learned, but it works. It's like a black magic. Good. And as I mentioned, the models are there. The libraries are there. So you can also use some like cloud services to train your model. And this one is called something Amazon recognition. So they have a specific feature when you want to train it to distinguish between something. So this is the Chihuahua or Muffin example. Here, I'm showing that you can even cascade or connect more models. For example, this one, it can be example when you have some message and you want to distinguish whether this is okay or there is something what you should not post. So you are processing some data, some post from the social media. If you have a link inside, you can have even video. And it distinguish one by one if it's okay, and then at the end you are also having some gate if none of those are explicit or somehow strange, then you can post it, or you can just mark it as non-publishable. So you can have much more complex models. Types of data. Here I wanted just to say that it can be structured, so you really have the value and to which one the value and key. Then you can have something in the middle, so you need to slightly process it, or you can have unstructured data, which can be a video or something that even before you start to process it, you need to find out what exactly is in the data. So there can be multiple iterations to even find out what you need to process. Different kinds of learning. Supervised, you have data and the label. So for example, you know that something has a specific color, and you can sort things by the colors. Or unsupervised, you do not have the label, so you let the algorithm to find some pattern, to group the things and to match it. So it can distinguish what is the cluster or what is the similarity between the new data, and then to predict some outputs based on what it already knows. Reinforcement learning, that's quite interesting, that you have some agent or you have a person who is teaching the algorithm. So it goes, imagine that I had the neural network and that you have the result, and it would just check if, yes, this is a correct result. So give a really high probability that this is correct. Or if it's wrong, then it would say this is wrong, and it has like much higher value for the training. Or also here we can imagine that this could be that we are teaching the algorithm, for example, to that it should not have something as an output. Like you should not tell me how to make a bomb, or you should not tell me something what is dangerous. And in many cases, we need the agents to do this. Also, there is a theory, and also it's used that it doesn't have to be a person. It can be also an algorithm, which is with some probability giving these examples. Yeah. So. Very Cisco in the AI world. We divided it into two groups, AI on and AI in. AI on means that where is AI running on our devices. I will tell you something in the next slide. And where is AI in? So in which our products is the AI used? So the AI, as I shown you, there is the training and interference. And even the big names, the cloud providers, some of them are using our very powerful routers for these training clusters. And why they are using these devices, because they have really high speed, 400G, maybe some of them even 800G per port, huge density. We have devices which are 36 times 400G per 1U. They are very power efficient. And one more thing, which I did not realize, is they are working well. When one of our colleagues, he was explaining us the training phase and the data pattern. And he mentioned that, imagine, there is some data, there is cluster of GPUs, maybe thousands of GPUs. They are processing the data, so every single, I will call it agent, receives this data. They calculate it for minutes, maybe for hours, and then they are exchanging this data. So the pattern of the data is like this. Everything, and it goes down. And if you have a cluster like this, and something breaks, then you are losing the cycle. Or it needs to be recalculated. So you really need the reliable devices. And of course, the GPUs itself, nowadays, mostly it's NVIDIA. There are different players, even some interesting startups, and the things around. Good. Then AI in, where we are using the artificial intelligence. This is an example when we have knowledge base. Cisco is there. Next year it will be 40 years. And we have the technical assistance centers. So when you have a problem, you raise a ticket, and they will help you. They have a huge database of what was being solved, and even some internal knowledge bases, logs, and so on. So this is what is being stored on our servers. And then there are the real live networks, which are providing a lot of telemetry. It can be some logs, it can be for example, NetFlow, which is showing you which kind of data are passing. It can be some security information, what is going on the end user stations, and then you connect it with some powerful algorithm, and again you train a model, and out of this, when you are hitting some new issue, you can send the logs, and it can either tell you this is the issue, or to the engineer, I need this and this more data, and I believe it might be this, or this. One of the examples like this is DNA Center, and you can imagine it like this. We have the network on the bottom, which is sending a lot of different logs, SNMP, some API calls, syslogs. I had a lot of those over there. Even the authentication, who is authenticating and where. The DNA Center itself, it's a very powerful server, so it has the trained model on itself, and it's processing what is happening in our network, and also sending anonymized data to our data centers. So based on the new data, the model can be retrained, and then we are receiving some insights. Or even with the upgrade, the new version of this model, it can look like this. So imagine that you have a big network, like Andrej mentioned, this XDR. So you have some panel, and you see that something is not working. This is harvested from a lot of information from your network. It can have some priority. This one has priority 3, so it's somehow in the middle. And you see that I think it's some interface is having some issues. And what is interesting is that it have processed the logs and find out there is an issue. And also here in the suggested actions, it have told me, collect these and these outputs. Here there was initially a button run, so it have collected this for myself. And here either I see the issue or not. Now, there are a couple more steps. Again, collect some data, check this and that. And the last one is that I can open a tag case for you, and I will already provide this information. So it gives you much farther than if I just open the case. I have an issue with the port. This one is sending the information. I have an issue with this port. These are the logs. These are the additional information. Help me. And remember, on the other side, it can be already taught in the model, and I can directly have an answer. This is one example. Another example is automatically opened cases. For some of the issues, if I allow it, it can open the case automatically, and I will just receive an email. You have this and that issue in your network. You should upgrade, or you should change the cable on this and that, or check the cable on this or that port. Or it can be that just you have an issue. Do you want to open me the case? It depends on what kind of customer it is, if it allows it, if they allows it or not. One example. AI in collaboration. Maybe this is something what we see very often. I would say the most often, but no. The most often we see some YouTube or Google algorithms, or maybe even Facebook or some other social media, which are based on our interest, offering some content which is just alluring you and does not allow you to leave the network. I think that one is the most one. What we see, but in Collab, at least for me, we have quite few examples. And here, again, the AI is here for many years. It did not start last year with the ChatGPT. So here we have an example of, we call it language intelligence, so some translations or the transcriptions. When we are having the meeting, audio or video, usually it's included video, it is writing what we have said. That's not so hard. But it's also writing a summary. Like, if you don't want to read 200 pages, it gives you 1 or 2 page summary. That needs much more intelligence than just to transcribe what you said. Audio intelligence. For me, this is essential because from time to time, quite often, I'm having the meetings and I'm moving from somewhere to somewhere. And I really want the other person to understand me. And maybe you realize that someone is in the train, someone is in the car, and you do not understand him well. So we have really powerful background noise removal. We even purchased some company on it. Speaker focus, when we have a room, even a room like this, there is usually more microphones, and it can detect who is speaking and trying to amplify the sound from this specific person and remove the noise from the others. Cinematic meetings, processing more videos and having the best focus on that person who is speaking at the moment. Here you can see how it all started. There is 1990, some echo cancellation. So that was some first processing of the voice, and then much more. And you can see that the last years there is really a lot of focus on the AI processing. Good. This is just 3 examples. Catch Me Up. So we have a software called WebEx that's for our audio conferencing. Maybe you know the other, like a Zoom. Microsoft has something, and many more. So Cisco is providing WebEx, and there is a chat, possibility to call, also with a video, and the endpoints. And it does not matter if it's a meeting or if it's just the group chat that we are having. It can nowadays provide you with we call it a catch me up, and it will show you the summary since what was the last time when I checked this space. And it's pretty powerful because sometimes it can be that I'm checking it every day, and it can be 5 messages, or sometimes it's just crazy and it can be 50 or more messages. So it really tells you what was happening. And even if there are some tasks, And you can even ask if I was mentioned, if there was something, some task given to me. Good. Send a perfect message. Sometimes we write a message which in some passion, and realize that maybe this is not the ideal to send to a boss or to a customer. We have the option to change the tone of the message. And translation. AI audio codec. This was quite interesting for me because there is a new codec which is based on some AI model. This one is developed internally. And you can see here is the quality, and here is how much data you need to send through a network. And you can see that we are finishing at 6 kilobits, and the quality is the same as the standard industry codec, which is you can say it's 10 kilobits, but it's much more. It's like 2.5 times more. And sometimes when you are having a lot of concurrent calls, this can change the thing. I know that I'm at the end of the time, so I will finish just 2 more slides. Here, I wanted to show you that the processing of data, it can be really a multi-step tasks. So here, this is about facial recognition, and this can have actually quite a few steps, because first you need to find out how many people are on the picture. Then you need to find out, okay, where are the people, select it and process the pixels, try to find out what are the significant parts of this person, and again, this is not everywhere, but we had to enroll into this. So we have enrolled and said, okay, my face can be processed. And nowadays, when we have meetings, even usually it's people from our companies and companies we closely work together because there is some trust. We can see the names and even positions of the other people. So I know that, okay, this is the developer, this is the guy I was writing emails for several months, so finally we see each other. So yeah, we see who we are talking about. And I wanted to say this one, responsible AI. As I said, there is some teaching of these models, and AI is really powerful. I think that it can do even much more than we can imagine nowadays, but there are some limits. And I read that there is some EU law which was they agreed on it quite recently, but it's trying to make us use the AI responsibly, because you know, if there are no limits, there are some strange things happening. So, for example, it's called responsible AI, and I will just say a few of those. So, false content. Imagine that you are just writing with some like ChatGPT or something like this, and you really start to trust it. And you ask it, okay, so who should I vote? It gives you some answer or not. And if it gives you some answer, how it decides who is the best candidate. You have there are ways how you can trick the algorithm. Like if I said why this person is the best candidate 100 times, it will add it into algorithm. Like, okay, someone is asking why he is the best, so why he is the best, he will make the investigation and add it to the algorithm. So there is, for example, one way how to influence it. Hallucination. I have a really nice picture. Sometimes, if the algorithm does not know the answer, it will just make it up. And this is a picture, but it can be also that I'm asking for some historical facts. And it tells me that the most famous quote on the internet is from Napoleon. Maybe not. So there really are examples when the AI just make the answer. Bias. This is quite touchy topic, because even us, we have some prejudices. And this is the same with the algorithms. So just know that there is some bias. Sometimes it is relevant, in many cases it is not, or it is based on some historical consequences. but it is there. Unanticipated output. I think this is, at least now, quite a big showstopper for many companies, that even if you ask the same question, or if you give to the algorithm the same data, sometimes in many cases it does not give you the exact same answer or result. So in some cases it is good, like if I'm asking write me some essay, so if we have the same topic, it will give us five different essays which we can hand over. But if you want to know, should I stop the car or should I stop the train, you always want to process the data in the same way. So here you need to be sure that the answer will be as you need it, and it depends on the seriosity or on the expectation. And deep fakes. I'm sure that you have already seen some picture, like put head in the holes, I think it's called. That you have some funny pictures and you put someone's picture on top of it, and he looks like, I don't know, Schwarzenegger or something. And nowadays this can be done even with the videos, and it can look really, really authentic. So let's see where this will take us. I have many examples in the slide deck. You will receive it, so you can check it, and thank you very much for your attention.